We're now going to look at part 2 of our lesson on combining results to see how parallel streams works internally. And this is going to show how to perform the reduction of combining partial results into a single result, but it also really emphasizes the common traps and pitfalls that can occur when you use parallel streams in order to do those kinds of things. And the really important thing to note here is that collect and reduce, which are the two most common terminal operations, have very subtle but important semantic distinctions. They don't work exactly the same. They don't have the same expectations and preconditions and so on. And so as a consequence, it's a good habit to get into to make sure that you test your code with parallel streams in order to make sure you haven't accidentally made some faulty assumptions about the semantics of reduce in particular. Reduce is the one that's really the tricky part. And that's because reduce expects to be doing mutable reductions on objects that are immutable. Sorry, not mutable reductions, immutable reductions on immutable objects. And if you accidentally put in something that's mutable instead of immutable, then really weird results will show up when you do things that involve parallel streams. So let's take a look at an example to make this clear. This is the Buggy Stream Reduce 3 program, and it's in my EX17 folder in my GitHub repository. So what this program does is it's going to convert a list of words into a stream of words. And in this particular case, that's going to be the work of Shakespeare or whatever. It doesn't really matter. All we know is we have a big set of words or a big list of words, and we want to turn them into a stream of words. And nothing happens at this point yet because everything is lazy under the hood. Now, depending on whether the parameter passed into this method, the Buggy Stream Reduce 3 method, is true or false, because it's Boolean, then the stream may become a parallel stream. If false is passed in, the stream stays a sequential stream, which is what it started with because of the fact that we called the stream factor method. But if we pass in a parameter that's true, then we're going to convert this stream into a parallel stream. And this is actually a pretty good idiom to be aware of. You can dynamically toggle between sequential and parallel streams simply by passing in a parameter and doing a trick like this, where you create a stream and then you conditionally make it a parallel stream. Otherwise, it stays a sequential stream. Now, what's interesting about the rest of the code is if we keep this as a sequential stream, everything's fine. But if we make it a parallel stream, then chaos and insanity is going to ensue. Incidentally, the last call to .parallel or .sequential in a stream is the one that will set the semantics of the stream. In this case, there's only one call, but you could have a call to .sequential, .parallel, .sequential. It would be a little strange to do that, but you can. And the thing to remember is that they don't toggle back and forth while the stream is running. The last one that gets called sets the behavior for the entire stream. So this code here works fine when the parallel flag is false. And that's because the string builder we're about to look at here is only going to be called in a single thread of control. You can see what we're doing here is we're saying new string builder, and then we're going to use append to add elements to the end of that string builder. And then when we're done, we're going to make a new string. This works fine if we're doing sequential streams because there's only one thread. So there's never any issue with race conditions. However, when the parallel parameter is true, then chaos and insanity will break out because string builder is intentionally designed to be non-thread safe. That's its purpose in life, is to only work correctly when it's called in a single thread of control. And when we start calling string builder operations in multiple threads, which would happen if we turn this into a parallel stream, then we're going to have all kinds of race conditions and corruptions of the internal state of the string builder object because it's intentionally not designed to have any synchronization. So it's distinctly not thread safe. So you can learn more about this at some of the links at the bottom of the page, but this code will fail very gratuitously and horribly if you aren't aware of the fact that reduce expects to have an immutable object to work on, not a mutable object. And string builder would be mutable because operations like append will change its internal state. There's a couple ways to fix this problem. One way to do this is to replace string builder with string and then use concatenation. So you can see here that we're going to concatenate the strings together by using the plus operation. This works fine, and this works fine because a string is inherently an immutable object in Java. If you recall, Java strings, once they're set, cannot be changed. And so anytime you do anything like concatenation, it's actually making a whole new string object that includes both pieces you're concatenating. The problem with that is that when you do concatenation, it ends up copying the data, and that can be very inefficient. So this approach works, but it's very slow. Probably a better way to do things is to use collect instead of reduce. And in this particular case, we're going to use the joining collector. And the joining collector is basically one that will work with a non-concurrent collector, so it'll work with parallel streams quite nicely, or sequential streams quite nicely. And it'll do the joining in such a way where we don't have to worry about race conditions because of the way that the streams framework handles the calls to various types of collectors in a parallel stream. So this is going to work just fine, does not incur any of the problems that we see that happen with reduce and the use of mutable string builder. So this is a much better way to go for that particular type of scenario. Some other things you have to be aware of when you're using parallel streams are issues associated with associativity and identity with the reduce method. So reduce does some cool things, but it's got some limitations you really have to be aware of. And to see these examples, you take a look again at my EX17 folder in my GitHub repository. And there's a couple of tests that illustrate the problems. The first test is called test difference reduce, and the second one is called test sum. So the code up here in test difference reduce is not going to work properly when used with a parallel stream, and that's because subtraction is not associative, and addition is associative. So A plus B plus C is the same as A plus B plus C, but A minus B minus C is not the same as A minus B minus C, if you understand the distinction there in the way I phrased it. And so as a result, when you use parallel streams, you're going to get incorrect values here because the implementation assumes associativity and subtraction is not associative. Here's another subtle problem. This is called test sum, and it works by passing in different values for the identity. That's the first parameter passed to reduce. Now, if you pass in for summing, if you pass in 0, then that is in fact the identity of addition, meaning that the identity of any operation is the identity op value equals the value, or value op identity equals the value. That's what's meant by identity. Unfortunately, for addition, if you were to pass, say, a 1 in here, you'd get the wrong thing because 1 is not the identity value for addition. There's also a similar test that works on multiplication, illustrating that if you pass in an identity that's not 1, you'll get the wrong result. So if you get confused and you pass a 0 in as the identity for multiplication, well, obviously that's not going to work because 0 times any number is 0, not the number, whereas 1 times any number is the number. So that's the identity value. So make sure you're squared on identity for addition and for multiplication, and also be aware of the fact that parallel streams don't work properly for non-associative operations like subtraction or division. This topic of collect versus reduce is actually broader and deeper than we have time to go through in this class. So if you want to learn more about these issues, please feel free to go take a look at this video that appears on YouTube by my good friend and colleague, Angelika Langer, who's an expert in many things, including Java and C++ and object-oriented programming and functional programming and so on and so forth. So she's got a bunch of good videos, and this is a good one that will go into more detail about these topics.